Hello viewers, welcome to another section of my tutorial, and in this video I have a concept in applied electricity, and that is power in AC circuits. Now when you say power is a work done per unit time. So in an electrical circuit, power is dissipated across the various loads. So now in our normal electrical circuit, that is a direct current, we use the resistors. So the power dissipated across the resistors is the only power in our normal circuit. When you come to an AC circuit has a lot of reactive components. We have the capacitors, we have the inductors. There is power dissipated across the capacitors, the inductors, and the resistors also. Now, the power dissipated across the resistor is different from the power dissipated across the capacitors and the inductors. Now, the inductors and the capacitors offer something we call reactance, whilst the resistor offers resistance. So these are the two oppositions in an AC circuit. So these two oppositions arise or brings about two different types of power in an AC circuit. So you have the active power and you have the reactive power. So now when you say an active power, the active power is the power which is dissipated across the resistor. So let's talk about the active power. So this active power is the power which is dissipated across the resistor, and it is the normal power we know, and each unit is in watts. So if you have any problem in AC circuits and you are being asked to find just power, then it means they are asking you to find the active power. That is the normal power. So calculate the power of the, meaning you are being asked to find the active power, and each unit is watts. Now let's talk about the reactive power. When we say reactive power, these are the power which is offered by the reactance of the circuit, and the reactance is from either the capacitance or the inductance. So for the reactive power, we have the reactance either in the capacitance or in the inductance. So from here we have each unit to be volts ampere reactive. Volt ampere reactive, which is also known as VAR. So this is the unit for reactive power, and this is the power dissipated across the reactance in an AC circuit. Then finally we have the apparent power. When you say apparent power becomes the resultant of the active power and the reactive power. Now since an AC circuit has two different power components, to find the effective power, or if you say the total power of an AC circuit, that is what we call the apparent power. So the apparent power now stands for the total power in an AC circuit, and each unit is volts amperes. So now let's come to the formula for finding these power components. Taking the active power, the formula for finding an active power is equal to IV cos theta. Now you ask why. Let's move forward, and I'm going to show you how this power or this formula came about. Now let's see that of the reactive. The reactive power becomes IV sine theta. Then finally our apparent power, which is the total power, becomes IV. So now we represent power with phases with a phasor diagram, that is phases. So reactive power is always on the y component here, that is Q. We represent it with Q. That is the reactive power. Then we have the active power here, P. So the resultant of these two give rise to the apparent power, S. Now we can see that the apparent power, S, is now leading the active power here, because it is up here and it is down. So it is leading. We say it's leading with a particular angle. we call it the phase angle, theta. So from here we can see that to find the active part of an apparent power, which is the total power, is simply the S cos theta. So we know that from here we can see that the active power P equals S cos theta, but our S, which is our total power, is equal to IV. So therefore our power becomes IV cos theta, and that is the active component of an AC circuit power. So for the reactive, you know that this scale, to find this scale, is simply this S sine theta. So you're going to have our Q to be equal to S sine theta, which is also equal to IV sine theta. So this is the formula and the way we go about by the power in an AC. Power in an AC circuit is not just a single power, but has two components, which is the active power risen by the resistors in the circuit, and you have the reactive power, which is also brought about by the reactive components such as the capacitors and the inductance. And you have the formula of finding the active power, IV cos theta, where I and V is the total current and the total voltage respectively. Our theta here is the phase difference between our total power and our active power, which can also be the phase difference between our voltage and current in the circuit. This is the end of my video. Thank you. Kindly like and subscribe. Then follow as I post questions on this topic. So I'll be posting various questions on the power in AC. So kindly subscribe so that you get notified when I post new videos.